Hello all. In this session, we will start with the I-type instructions in Risc processor design. So we will see I-type instruction set. So I will again open my instruction memory. So in this instruction memory, so these are all R-type instructions: add, subtract, SLL, XOR, SRL, SLL, and OR and so up to here, these are all R-type instructions. So we have seen add instruction. For subtraction instruction also same. So for example, if you want to consider the subtraction instruction in R-type, so you are giving the instruction in binary form like this. So you are providing the instruction in this format 0x800100B3. So this is subtraction. So the instruction will be fetched from this memory by the and it will be given to instruction code with the help of PC program counter. After fetching this addition instruction, the PC will be incremented by PC plus 4. Okay, so initial the PC value will be equal to 0. Next it will be incremented by 4, and the subtraction. So initially PC will be equal to 0, right? So initially PC will be pointing to 0. So it will be incremented internally in the instruction memory up to 4 locations. Sorry, up to 3 locations. Next, by the instruction fetch unit, again this PC will be incremented by PC plus 4, which means our PC value will be equal to 4. So internally in the instruction memory unit, what happens? This will be internally incremented. That is PC value equal to 5, 6, 7. Up to this values it will be incremented, and the instruction or the binary data which is present in this following locations 4, 5, 6, 7. Here you can observe here 4, 5, 6, 7. This binary data will be fetched out and it will be given to instruction code. So this instruction code is given to our top module, top Risc, from the instruction memory. You can see same process. This will be given to our top, and that will be given to our control unit as well as a data path unit. So in the control unit will be evaluating the instruction based on the function 7 and function 3 value. It will decide whether it is a subtraction or shift left logical or shift less than shift set less than or set less than unset. So based on that it will decide, and the ALU control value will be decided, and according to the ALU control value, again it is given to the top Risc. So the ALU control value is given to the top module. So from there it is again given to ALU module. So in the ALU module, according to the ALU control signal, the operation is performed, whether it may be addition operation, subtraction operation, shift left logical operation. That operation will be performed and will be stored in the result. So this is R type instruction. Okay, so in R type instructions also various type of operations like addition, subtraction, shift left, XOR, and or all this will be performed. Now coming to I type instructions. So in the instruction memory I will show the I type instruction. So coming to the I type instruction here, you can observe from here we are going to start with I type instructions. So in I type instructions, you have add I, SLLI, XOR immediate, or set less than immediate, shift right logical immediate, or immediate, and immediate. All these are I type instructions, right? So in this type of I type instructions, you can observe. So for example, let's consider this add I instruction. Okay. So in this add I instruction, so in this case of add a instruction, before discussing about this, first let's revise or recall our I-type instruction format. So our I-type instruction will look like this. So it will be immediate of 11 down to 0, immediate of 11 down to 0, that is 12-bit immediate value, followed by RS1 and RS2, and sorry, not RS2. We have function 3, RD, and opcode. This is the format of our I-type instruction. So this is 31 down to 20, that is 12-bit, and this is 19 down to 15, and this is 14 down to 12, 11 down to 7, 6 down to 0. So this is this many bits, total 32 bits, the I-type instruction. Here, observe here the immediate value is of only 12 bits. Okay, immediate value is of 12 bits. So I've taken some example framing this particular instruction. So for add I have taken proper values so that it will be our addition instruction. Okay, so following the opcode everything. So I have taken that particular I type instruction. Okay, so coming to this I type instruction now, what we will do is. Uh, we have stored, right? So we will fetch the instruction like R type instruction only. Okay, so we will fetch this R type I type instruction from the memory locations. So sequentially we will fetch every instruction, so it will take some time to fetch this particular I type instruction, so it will be in sequence order. After completing add instruction only, we will be fetching our add instruction. Okay, so after fetching this, it will be given to our instruction code, from which it will be given to our top model. This is same. Okay, so from the top module again, it will be given to our control unit as well as data path data path unit. Okay, so in the control unit, now let's see what is happening. So control unit, what happens? Function 7, function 3, and opcode, right? Opcode and ALU control we have. So here opcode for R type instructions is 0110011, right? So but this will come under R type. So but in I type instruction, what I have provided the opcode, which is 0010011. In the instruction, if you convert the hexadecimal format into binary format, you will observe this is the opcode which I have provided for this I type particular instruction, add I instruction. So the opcode which I have provided is 0010011. Okay, so if this is the opcode, then the loop will enter here. So this is I type instruction. So initially mem to reg will be equal to 0, b equal to 0, b n equal to 0, jump is equal to 0, lb is equal to 0, and hw is equal to 0. And considering the case of function 3, so if it is 000, we will consider it as add immediate. So while framing the instruction, what I've done is I've made function 3 000 for add immediate. Okay, so when add immediate, if function 3 is 000, then ALU control is 001011. Okay, this ALU control is again given to our top model. So it is given in our top model. You can observe this is the ALU control signal, which is given which is given to top module, and from the top module again we are giving it to our data path unit, DPU unit. Okay, wait a minute. We were discussing I type instruction. Yeah. So from that ALU control signal will be given to our DPU unit. Okay. So here the ALU control signal is given to our DPU unit. Okay. So in this DPU unit, you can observe this ALU control signal. Again, this ALU control signal is given to our ALU unit. So it will be given to our ALU unit. And since we are discussing about I-type instruction, so here you can observe the ALU control value which is given by our control unit is 001011. Okay, so this is the value for I-type instruction, and the result is source 1 plus immediate value underscore R. So here add I for add I instruction in ALU, what we are doing, result is equal to source 1 plus immediate value underscore R. Okay, previously in case of add instruction, normal R type instruction, we have add, right? So what we are doing, we are doing just simply result is equal to source 1 plus source 2. Okay, this source 1 where we are getting from register RFU unit, right? Previous session I have shown you. Okay, and this where we are getting from the RFU unit only. Okay, this process I have shown in the previous sessions. Okay, now here you can observe in the case of add immediate instruction, source 1 is coming from RFU unit only, register file unit, and this immediate value is provided in the instruction itself. In the theory sessions also we have discussed the immediate value is provided in the instruction itself. Okay, we have seen the instruction I type format, right? So this is the I type format. This is where we are providing the immediate value in the instruction itself. But this is 12 bit. This is 12 bit. We have to sign extend the value. Sign extend this value to 32 bits. To 32 bits. Okay. So this 12 bit value we should sign extend to 32 bits. So now let's see what is this sign extension and how can we extend to 32 bits. So for example, if we have a 12 bit value, say 1011, 0011 and 1111. Okay, this is our 12 bit value. Okay, now if we want to change it into 32 bit sign extended value, 32 bit sign extended value. Now what we are going to do is to convert this into a sign, wait a minute, into a 32 bit sign extended value, what we are going to do is, now we are going to, so we will maintain these values as it is, all the values as it is, and we will extend the value. We will consider this MSB and we will fill the all remaining 22 positions. So this is 12, right? 12 plus, uh, sorry, 12 plus, yeah, all the remaining values with the MSB itself. Okay, is it clear? So we will extend this all the remaining values with MSB itself. Okay, so this is how we'll perform sign extension to this immediate value. So this sign extension we will be doing in the top module. So here we in the ALU we want immediate value R, which is a sign extended value. So this value is extended in the top module itself. I'll show you. So in the top module you can observe. So after the instruction which is being fetched from our IFU, sorry, instruction memory unit, this instruction which has been fetched out from our instruction memory unit, that to that we will be making modifications in the top module. So this is the top module, right? So here you can observe the process of sign extension. So what we are going to do is we are maintaining our 32 31 down to 21 value as it is, that is the value as it is, and we are making extension to the MSB. So we are replicating the MSB 20 times. Here you can observe we are replicating the MSB 20 times. So the MSB value is replicated 20 times and the remaining value is placed as it is, and we is given, and this is given to immediate value top, which is one of the wire, so it is declared as wire. So this immediate value underscore top is given to our DPU unit. So after sign extension of this particular instruction 31 down to 21, you can observe. So here this is 31 down to 21. Okay, so after, yeah, so this is 31 down to 21. Okay, so after doing the sign extension to this particular value, we are giving it to our uh, immediate value underscore top. So this immediate value underscore top is given to DPU unit. So this DPU unit further gives, so here you can observe this is the immediate value. So this is further given to our ALU unit. Okay, so like that our ALU will get the immediate value, so that we can perform any operation. It may be addition operation or shift operation, right shift operation, left shift operation, anything with the immediate value, and the result is stored in the variable called result. Okay, so the type of operation, again we know that it will depend upon the ALU control signal. Okay, so this is how we'll perform all the operations. Up to here we are going to perform this immediate value, you can observe. And yeah, and coming to this shift amount, in case of shift operations, I think in R type we haven't seen any shift operation with, yeah. So in case of R type, what happens is, already we have discussed, in case of R type instruction, what is happening? In case of shift operation, RS1 is left shifted by RS2, the value present in RS2. So the value present in RS1 is left shifted by the value present in RS2, or in case of write operation, the value present in RS1 is right shifted by the value present in RS2. Let's say if RS1 consists of value 5, so it is left shifted by the value which is present in RS2, that is like this. Or in case of right shift operation, 5 right shift by, like this, the left shift and right shift operations will be performed according to the value which is present in our registers. Okay, now in case of this I type instruction, what happens is, one value will be present in RS1, source register 1. Okay, one value will be presented in our source register 1, and the shift amount, to which amount it should be shifted, will be given in this immediate value, will be given in this immediate value. Okay, so this is shift amount. This we have discussed in our theory sessions also. Okay, shift amount, this is given in the immediate value itself. It will not stored in the register, since it is a I type instruction. The immediate value shift amount will be given, whether it may be left shift, right shift, arithmetic right shift, or arithmetic left shift. All this will be given in the immediate value itself. The shift amount will be given in the immediate value. Okay, I hope this is clear. Now let's see from where the signal shift amount is coming. So this is input to our AL unit. So in the DPU unit, we will see, this is our DPU unit. Yeah, this is shift amount, which is of 4 bit. And the DPU unit is getting from top module. So in the top module, you can observe where is this shift amount. Yeah, this one. Instruction out 24 down to 20. I think this one only, right? SHAMT. Okay, so how much this is? DPU unit 3 down to 0, that is 4 bit. And top Risc 24 down to 20, which is actually 5 bit. Okay, so this is given to our shift amount. Actually it should be 24 down to 21. Okay, since 4 bit, right? So this is given to our shift amount. Okay, so in case of shift operations, we have seen, right, uh, in the theory sessions we have seen, in the instruction itself, the 4 bit shift amount is given. Actually this should be 24 down to 21, 24, yeah, 24 down to 21, and this is given to our DPU unit. Okay, so from here we are giving it to our ALU unit. Okay, so we are slicing the instruction itself. Okay, we are not any from elsewhere, we are not getting, we are slicing the instruction itself and giving the shift amount value to from our top to our DPU to ALU. Okay, so like this we will give this shift amount in case of shift operations. Okay, now, so this is our about shift operations, and rest all is same. You can observe shift amount. Yeah, let's all is, rest all is same. Okay, so this is I type operations in Risc. So this is how we will design the I type instruction. And yeah, so this is about I type instructions in Risc. So if you are having any particular doubts or queries, you can ask me, or else we can end this session. Thank you.